Good morning, students. Today we are going to see the introduction to cam and follower mechanisms. Cam and follower mechanisms are fundamental in mechanical engineering. They convert rotary motion into linear or oscillating motion. They convert rotary motion into linear or oscillating motion. Otherwise, we can say cam is a rotating element that converts linear or oscillating motion of another member called follower. These mechanisms are widely used in various applications. Today we are going to see the types, motions and design aspects of cam and follower mechanisms. We will also explore these applications across different industries. We will see what are the types of cams. First one is the disc or plate cam. Second one is the cylindrical cam, and third one is the clovoidal cam. The first type, disc or plate cam, is the most common one used in variety of the industries. Follower moves perpendicular to the cam axis. In disc cams, follower movement will be perpendicular to the cam axis, used in automatic valve trains. Next one is the cylindrical cam. Cylindrical cam, the follower will move in an axis parallel to the cam axis. This type of cam is used in the textile machinery. Clovoidal cam. Follower moves in a complex 3D path. In clovoidal cam, the follower will move in a complex 3D path. This is used in precision indexing mechanisms. The clovoidal cam mainly used in precision indexing mechanisms. Next, we will see what are the types of followers. First one is the roller follower, second one is the knife edge follower, and third is the flat faced follower. In the roller follower, in the surface area will be a roller. Between the follower and the cam will be a roller type one. It reduces friction, suitable for high-speed applications, commonly found in automotive engines. Roller follower will find application in automotive engines. The second one is the knife edge follower, which has a simple design and higher wear for low-speed applications in older mechanical systems. So the knife edge follower will be used for low-speed applications. Low-speed applications, the knife edge follower will be used. The last one is the flat-faced follower. It distributes load, can cause noise and vibration, used in simple automation. Flat-faced follower is used in simple automation. So, in the next section, we are going to consider the various aspects of follower motion. In the earlier classes, we have known what is the displacement and the velocity, acceleration and all. So, displacement is nothing but the linear or angular movement of the follower. So, we earlier see what is displacement. It is the movement of a particle is displacement. We have already seen in earlier classes. Now, in the cam and follower motion, the linear or angular movement of the follower is called displacement. It is graphically represented. The velocity, what is velocity? It is nothing but the rate of change of displacement. The rate of change of displacement displacement is called this velocity. It affects jerk and vibration. Velocity affects the jerk and vibration. Next one is acceleration. It is nothing but the rate of change of velocity. It impacts dynamic forces. The acceleration impacts dynamic forces. The fourth one, we are going to see for the first time in the Kamenev follower motion, the jerk. What is jerk? Jerk is nothing but the rate of change of acceleration. Is the fourth one, rate of change of acceleration. It is very crucial for smooth operation of the Kamenev follower. So these are the four important aspects we consider in the follower motion. Next, we will see what are the important Kamenev follower motion profiles. In Kamenev follower motion, there are four kinds of motion available. First one is simple harmonic motion. First one is the simple harmonic motion. Second one is the uniform velocity motion. Third one is the uniform acceleration and retardation motion. And finally, cycloidal motion. These four kinds of motion are available in the Kamenev follower. Now, let us see what are the different kinds of displacement diagram available for the different kinds of follower motion in the Kamenev. First one is, this one is the velocity, uniform velocity motion. Uniform velocity motion. In the x-axis, the cam angle theta is noted in the x-axis and the s is the lift noted in the y-axis. For the bulk period of the cam, the horizontal line will lie in the x-axis, and for the uniform velocity motion, a straight line joining the diagonal of the rectangle will be for the rise of the follower. Again, the bulk period will be noted as a horizontal line, and the return motion will be noted in the straight line of the diagonal of the rectangle. And again, finally, this is the bulk period. So, for uniform velocity motion, we consider straight lines of the diagonals for the displacement diagram. Next one is the simple harmonic motion. For simple harmonic motion, first to draw the x-axis of the cam angle and lift follower motion in the y-axis and draw a semicircle on that lift portion and divide that into suitable portions. Divide the semicircle into suitable portions and rise period into equal number of portions. And draw the horizontal lines and vertical lines. You will get a smooth curve for rise. Similarly, for return also, we have the same horizontal line and vertical line concept, and smooth curve is drawn for the return. Curve period will be noted as the horizontal line. This is for the simple harmonic motion. Next one is for the uniform acceleration and retardation motion. For uniform acceleration and retardation motion, the following procedure is employed for constructing the displacement diagram. First, the rise period is divided into equal number of parts, and the midline of the, in the vertical line, the midline of the portion is divided into same number of equal parts. Same number of equal parts. Then join the first corner with the first division, second division and third division, and the last corner with the fourth, fifth and sixth division. Say any number of equal parts. You can get a smooth curve in the rise portion, in the uniform acceleration portion, and for retardation, same principle is employed and a smooth curve is obtained. For bulk period, a horizontal line will be drawn with the displacement diagram. This is the procedure to draw the displacement diagram in the uniform acceleration and retardation motion. The final one is the cycloidal motion. The final one is the cycloidal motion. So, the cycloidal motion, we apply cycloid principle. First, in the x-axis origin, a circle is drawn and this circle is moved towards the rise portion, and the dwell portion is noted as a horizontal line, and finally return portion is also a cycloidal portion will be noted. So for cycloidal motion we apply cycloid principle to draw the displacement and displacement diagram for the Kalman follower setup. These four motions are employed in the different profiles of the Kalman follower motion. Now let us consider the design considerations for Kalman follower setup. The three main design considerations are pressure angle, undercutting and material selection. The pressure angle is the angle between follower motion and normal to the mixture of the cam. It should be less than 30 degrees. So, the pressure angle should be less than 30 degrees. Undercutting is nothing but the removal of material on the cam profile. So, it is avoided by base circle selection. So, undercutting is avoided by base circle selection. Finally, we see the material selection for different aspects of the cam profile. Based on the load, speed and environment, we select the common materials as steel, cast iron and polymers for the cam profiles. Applications. What are the applications of cam? Mainly in the internal combustion engines. In the internal combustion engines, different kinds of valves includes inlet valve and outlet valve should remain open for some time and should be closed for some time. For this purpose, cam and follower setup is used. To valve actuation, performance characteristics based on the cam load design. So, to open an inlet valve or outlet valve, cam and follower is very important consideration in the internal combustion engines. Cam and follower find applications in robotics also. Precise motion control and pick and place robots are using cam and follower setup, mainly using. Cam and follower find application in the textile machinery also. In weaving, knitting and spinning, cam driven looms are running with the help of cam and follower setup. So now we come into the summary and conclusion section of the presentation. Cam and follower mechanisms are versatile for converting rotary to linear motion. So rotary to linear or sometimes oscillating motion. Key factors include cam and follower types, motion profiles and design consideration. We are seeing some aspects of cam and follower types, motion profiles and design considerations. There will be a wide range of applications. Future trends include advancements in materials, manufacturing and control systems for improving performance of the cam and follower. This is the main aspects of the cam in this section. We will see more aspects in the future classes. Thank you for the listening the presentation. Thank you for all.